Okay, in this video we're going to do kind of a short review of some concepts in trigonometry. So certainly knowing the unit circle, which is pictured here, would be very beneficial. It is essential to know for doing all our trig stuff. And then I get some other properties there. So on the unit circle, the sine of an angle on our unit circle here is going to be the y-coordinates. The sine is also an odd function, so the sine of a negative angle is the same thing as negative sine of the positive angle. Cosine is going to be the x-coordinates. Cosine is an even function, so the cosine of a negative angle is the same thing as the cosine of a positive angle. And then the tangent is going to be the y over the x, and then provided the x is not 0, and tangent is going to be an odd function. And then for reference, what the cosecant of theta is, the secant of theta, and the cotangent of theta is. So we're going to be dealing primarily with sine, cosine, and tangent here. So we're going to go ahead and practice doing some evaluating of some trig functions. So first thing we'll do is we'll find the sine of 210 degrees. So 210 degrees is on the unit circle, so here it is. The sine's going to be the y-coordinate, which would be minus 1/2. So the cosine of 210, that's going to be the x-coordinate, which is root 3 over 2. And the tangent of that same angle is going to be the y-coordinate of negative 1/2 over the x-coordinate of negative root 3 over 2. So the negatives will absorb, and then we'll go ahead and flip the fraction. And so we'll have root 3 over 3 after we have rationalized that there. Okay? And we can certainly do that in radians, pretty much the same idea there. Okay? So what if we give you a larger angle here? So what if I give you 945 degrees? That doesn't fit on our unit circle here, what we have drawn in, but it will be there somewhere. So 360 is going to be a full revolution. So we want to know how many full revolutions we got going on there. Oops. So let's see what we got going on here. All right. So how many full revolutions are in 945? Well, I think there's going to be two. 2 revolutions is 720 degrees, and the leftover is going to be 225. So we're going to spin around once. There's 360, and then 720, and then we're going to go another 225 degrees, and so we're going to end up right here. And so once we've done that, then it's going to be essentially the same thing as the previous example. So the sine of 945 degrees is the same thing as the sine of 225 degrees. And that's going to be the y-coordinate of root 2 over 2. The cosine of 945 degrees is going to be the same thing as the sine of 225 degrees. Cosine of 225 degrees. And that's going to be negative root 2 over 2. And finally, the tangent of 945 degrees is the same thing as the tangent of 225 degrees. And that's going to be y over x, but both the y and the x are negative root 2 over 2, so it's going to be 1. Okay? And I think we'll do 1 or 2 more here. I forget how many more examples we got. So we'll get this out of the way so we can have that nice unit circle in front of us. Okay, so what if I asked for the sine of negative 540 degrees, okay? And so I'm going to use the fact that the sine is an odd function, so this is going to be the same thing as negative sine of 540 degrees. 540 degrees is not on our unit circle, so we're going to see how many 360s are in 540. There is 1, and the remainder is 180. So to get to 540, we'll do a 360, and then we'll go to 180 there. So we'll be looking at that ordered pair there. Okay, so this sine of negative 540 degrees is going to be the same thing as negative sine of 180 degrees, and that y-coordinate is 0. The cosine of negative 540 degrees, cosine is even, so that's the same thing as the cosine of 540 degrees. And then 540 degrees is in the same location as 180 degrees. And the cosine of 180 is -1. And finally, the tangent of negative 540 degrees. We can slide that negative out and make that negative tangent of 540 degrees because the tangent is an odd function. And that's going to be negative tangent of 180 degrees, which is going to be negative 0 over, it should be -1 actually. And that is 0. Okay? And for good measure, we'll do one with radians here. So very similar if we're going to do it with radians. So what if we want to find the sine of negative 2 pi over 3? And so we're going to use the odd property here. So that is going to be equal to negative sine of 2 pi over 3. So we'll locate 2 pi over 3, which appears to be right here. And so that is going to be negative root 3 over 2. We forgot the negative. Okay. The cosine of negative 2 pi over 3 is going to be equal to the cosine of 2 pi over 3 because the cosine is an even function, and that's going to be equal to negative 1/2. And I don't really like this negative. Let me give it a better negative here. This was negative here. All right. And then the tangent. Okay, so we're going to play the same game. So tangent of negative 2 pi over 3. The tangent is on, so we can slide the negative out. Negative tangent of 2 pi over 3. And so that is going to be the y-coordinate, which is negative root 3 over 2, divided by the x-coordinate, which is negative 1/2. Okay, so that's going to be root 3. All right, so moving on to the next page, we're going to do kind of brief sketch of sine, cosine, tangent, and we'll also grab the secant. Talk about what's called the restricted domains, and we want a restricted domain so that we can have an inverse function, so we pass the horizontal line test. So here's the sine of x, and then we're going to use radians, so 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then the sine of those values I can grab right off the unit circle, so those are just the y values, okay? And then we'll go ahead and plot those points and then graph our sine wave. Now I'm actually going to go back to negative pi over 2 because that's going to be part of my restricted domain here. So here is our graph of our sine wave. Okay, and so we can do any branch that passes the horizontal line test. So the agreed upon method in most books is going to be from negative pi over 2 to pi over 2. That passes that horizontal line test. Or we can use pi over 2 to 3 pi over 2, or we have infinite possibilities. So the agreed upon is from negative pi over 2 to pi over 2. If we restrict our sign there, then we have a one-to-one function, so we can have an inverse. Okay, so our restricted domain is going to be negative pi over 2 to pi over 2. Okay, so there it is. So then our sine function is going to be negative pi over 2 to pi over 2 as its restricted domain, and the output of the range here is going to be -1 to 1. So if we're going to talk about the inverse, called the arc sine, that's going to have the output of sine as its input, so -1 to 1, and then the output of the sine, arc sine, is going to be the angles from negative pi over 2 to pi over 2. So later on when we're considering that, on the unit circle, here's negative pi over 2, and here's pi over 2. So what you're looking at is quadrants 1 and quadrants 4 when we get into doing some evaluations of the inverse trig functions. Okay. And so if we want to graph this, get ourselves a rough sketch of what the arc sine looks like, When you're when you're going to graph the inverse, you can take the original function and switch the x and y, switching the domains and ranges. So I'm going to take a couple of key points on my sine curve, and I'm going to switch the x and y pairs. So I can have a rough sketch of the arc sine. Okay, so there is a rough sketch of the arc sine. And then we'll mention the cancellation properties. So if our input is between negative pi over 2 and pi over 2, we're going to feed that to the sine first and then feed it into the arc sine. So the arc sine of the sine of x, as long as the x is between negative pi over 2 and pi over 2, the arc sine and the sine will cancel each other out, and you're left with x. If x is in the restricted domain, or is in the domain of the arc sine, then the sine of the arc sine of x will be equal to x. So then, in that context, the sine and the arc sine will undo each other. Okay. We can also, because we have a rough sketch of the graph, we can also answer some questions about limits. So, for example, if I asked you what's the limit as x approaches negative 1, I'm sorry, 1 from the negative side, so that would be from the left side, what's the graph doing of the sine inverse? It looks like it's going up to pi over 2. However, if I ask you what's the limit as x approaches 1 from the positive side, so over here, that's actually outside the domain, so this limit does not exist. Okay. And if we wanted to talk about the limit as x approaches 1, it would not exist because it does not exist from the right-hand side. Well, in order for a limit to exist, it needs to exist on both sides, and they have to be equal to each other, both the left and the right-hand side. Okay, so we're going to go ahead and look at cosine. We won't use the arc cosine too much. It's the arc sine, the arc tangent, and the arc secant that we'll use the most. So we'll go ahead and do a very similar treatment with the cosine here. We'll actually have our restricted domain between 0 and pi, so we won't have to backtrack into any negative angles here. So I get those y values for the cosine here. That's just right off my unit circle, those x coordinates there. Okay. Okay, and then we'll graph our cosine graph. Okay, and then we're going to use 0 to pi, and that's going to ensure that we pass the horizontal line test, so we have a inverse function. So the restricted domain for the cosine is 0 to pi. So when we're looking at our cosine of things, it's going to give us an angle between 0 and pi. So we're only looking at quadrants 1 and 2. Okay. So the cosine is going to take the restricted domain 0 to pi, and then that's going to dump that into minus 1 and 1. To find the domain and range for the arc cosine, you just switch the domain and range for the cosine. Okay. All right, and then if we want to do a rough sketch of arc cosine, we're going to do a very similar construction that we did for arc sine. We're going to switch a couple of those ordered pairs there. Okay, and one more. There we are. Okay, cancellation properties. If x is in 0 to pi, so that would be feeding that x into a cosine first. The arc cosine and the cosine are going to undo each other. Now, if x is in minus 1 to 1, that's the domain of arc cosine. The cosine of the arc cosine of x will undo each other. And, oops, not 1, it's x. Okay, we can also answer questions about limits, or ask and answer questions about limits. So if we approach 1 from the negative side of the inverse cosine, that is going to be 0, but we cannot approach 1 from the positive side. That's outside the domain, so we say that that does not exist. Okay. Okay, so we're going to move on and we're going to look at the tangent. So here is the tangent of x, and we're going to center it around 0. So it's going to be very similar to what we do with the sine. And I'm going to also include pi over 4 and negative pi over 4 because those are nice values for the tangent there. Let me erase this. This is pretty messy. I'll rewrite that. Negative pi over 4. Okay. All right. So at negative pi over 4, it's going to be undefined. That's a vertical asymptote on the tangent. And then we have negative 1, 0, 1, and then a vertical asymptote at pi over 2. So we'll go ahead and use that information to do a rough sketch of the tangent graph. Looks like we need a negative here. Okay. Asymptotes at negative pi over 2 and pi over 2. Plot those other points. All right, so there's our tangent, and that is one period of the tangent, and one period of the tangent here is going to pass that horizontal line test. So if we're talking about a restricted domain for the tangent, it's going to be negative pi over 2 to pi over 2. Slightly different than for sine, because we can't include the negative pi over 2 and the pi over 2. That's your vertical asymptotes. Okay, so tangent on the restricted domain, negative pi over 2 to pi over 2. And that's going to be onto the real numbers. So that's going to be a range of minus infinity to infinity. So the arctan will eat whatever you feed it. So it's not picky about what numbers you give it. Okay, so it's going to go minus infinity to infinity, negative pi over 2 to pi over 2, that being the arctangent. Okay, so we're going to do the same switching of x and y's here. Now, since our vertical asymptotes are negative pi over 2 and pi over 2, that's x equals pi over 2 and negative pi over 2. So when we switch x and y's, those becomes y equals negative pi over 2 and pi over 2. So our asymptotes will become horizontal asymptotes at pi over 2 and negative pi over 2. So we'll have those horizontal asymptotes. And then there's the graph. Okay. And we can mention the cancellation properties. So if it's arctan of x, the x needs to be in between negative pi over 2 to pi over 2. If that's conditions met, then the arctan of the tangent of x will undo each other, and we're left with x. If x is in negative infinity to infinity, then the tangent will undo the arctangent for any real number. Okay. Now this question ends up coming up when we get into like improper integrals and maybe some limits, and we're taking a limit of arctan of something. And so if I know what the graph of the arctan looks like, that makes this question a little easier. So if I ask you what's the arctan of, or what's the limit as x approaches infinity of the arctangent of x, well, we can see that that is approaching its horizontal asymptote of pi over 2. Now, oops, let's go back. Hold on. Now, if we're going to minus infinity, the arctan is approaching negative pi over 2. Okay. All right, so now let's run on to the secant and the arcsecant. So we're going to take a look at the secant of x. And we can generate this table from the cosine table by taking the reciprocals. And so our particular book uses a certain restricted domain for the secant. There may not be a agreed upon restricted domain. So I think what our book does is it tries to keep it similar to the cosine. We will have to hop over pi over 2 because that's a vertical asymptote, but it's going to be 0 to pi excluding pi over 2. Okay. All right, so reciprocal of 1 is 1. Reciprocal of 0, we can think of that as our vertical asymptote. Reciprocal of negative 1 is negative 1. Reciprocal of 0 is vertical asymptote, and the reciprocal of 1 is 1. So we can use that information here to graph one period of the arc secant here. Okay. Okay. And so what our book's going to use is 0 to pi over 2. We got to skip pi over 2, and then pi over 2 to pi. Some books might use a different variation so that we pass the horizontal line test, but we're going to go with this one. So our restricted domain is going to be 0 to pi, excluding pi over 2, so this is how we write it as an interval. So the secant is going to take 0 to pi over 2, union pi over 2 to pi, and the range there is going to be minus infinity to -1, including -1, union 1 to infinity. So if we want to look at the inverse here, the arc secant, so I guess we can call that negative, whoops, well, not with that one, -1. Arc secant will reverse the domain and range here. Okay, so we'll switch the x and y's again. So we will have a vertical asymptote of pi over 2 can be converted into a horizontal asymptote of pi over 2. Okay, and so now we have the graph there. We'll go ahead and mention the cancellation properties like we have in the other examples there. This doesn't come up as much, the cancellation properties for the arc secant, but the arc secant graph may come up and we may be asking limit questions about it. So there's your cancellation properties for secant and arc secant. Okay. If I ask you a question about the limit, if we go to either plus or minus infinity, the inverse secant, and that's going to be pi over 2, plus or minus infinity. Okay, so if we go to plus or minus infinity, the inverse secant is going to approach pi over 2. So we want to kind of have an idea what the graphs look like so that when we end up coming across limits there of inverse trig functions, we have an idea what the graph looks like so we can answer that question. Okay, so the next thing we're looking at is a little bit of evaluating trig functions without a calculator, inverse trig here. All right, so let's speed this up a little bit. All right, so we're going to evaluate without a calculator. So the arc sine of -√2 over 2, okay? So this is asking us what angle is the sine of, okay, so what angle is the sine of that angle, -√2 over 2? So on my unit circle, and the y sine is the y, so we're looking at this here. Okay, and that's 5 pi over 4. And we're also looking at this over here, which is √2 over 2 and -√2 over 2. And that is 7 pi over 4. Now, if we're talking about arc sine, it's going to spit out angles in either quadrant 1 or 4. And that's going to go from negative pi over 2 to pi over 2. So we're going to have to rewrite this angle here as a negative angle. And that would be negative pi over 4. Okay, so this would be a negative pi over 4, that angle measurement there. And that fits between negative pi over 2 and pi over 2. Okay. So negative pi over 2 to pi over 2. All right. How about the arc cosine of √3 over 2? So this is going to give us an angle in either quadrant 1 or quadrant 2. Here's one ordered pair. This is cosine, so we're looking at the x-coordinate. So √3 over 2 and 1/2, that's going to happen at pi over 6. The other place that's going to happen is at 11 pi over 6. And that's just going to be pi over 6 because that happens between 0 and pi. So we didn't have to work that one at all. Okay. All right, how about the cosine inverse of negative 1/2? So where on the unit circle is the x-coordinate minus 1/2? Here's one place. It's going to be 2 pi over 3. And the other place is going to be at 4 pi over 3. And which one of those is between 0 and pi? That's 2 pi over 3. And that's it. Didn't have to work too hard there. All right, how about the arctangent of negative root 3 over 3? So if I take 1/2 divided by root 3 over 2, so this would be your y over x here, okay? And we'll go ahead and rationalize that. That gives us that root 3 over 3, okay, so that's your y and your x. So we're looking for the y to be 1/2 and the x to be root 3 over 2, or both of them to be a negative, so a negative 1/2 for the y and a negative root 3 over 2 for the x, so that we have the tangent being root 3 over 3. Oh, it was negative, sorry. So scratch what I said. One of these needs to be negative, not both of them, okay? All right, so where does that happen? So here the x is negative and the y is positive, or in quadrant 4, okay, so that's where one's positive and one's negative, all right? Now, we're talking negative pi over 2 to pi over 2, okay? So that's talking about quadrants 1 and 4. So 11 pi over 6 is what we want, but that's too big, so we need to write it as a negative angle. And so as a negative angle, that is going to be, I believe it's going to be negative pi over 6. So it's going to be negative pi over 6. Let's clean this up. That's kind of messy. Okay, so that's going to be pi over 6. A negative pi over 6, pardon me. Okay, let's do a couple more. We're getting pretty long on the video here. All right, so what do we got going on here? We got the arctan of 0. Okay, so between negative pi over 2 and pi over 2. 0 is the same thing as 0 over 1. That's your y over x. That happens at 1, 0. So the arctan of 0 is 0. How about the inverse sine of root 3 over 2? So that's going to happen two places. One of them will be pi over 3, and the other one will be 2 pi over 3. And which one fits between negative pi over 2 and pi over 2? That's the pi over 3. All right. Let's move on. How about the arc sine of the sine of pi over 4? Okay. And pi over 4 fits between negative pi over 2 and pi over 2, so cancellation property just gives us pi over 4. Okay, so we're in that restricted domain. So they just undo each other, we're done. But what if we did something like the arc cosine of the cosine of negative 3 pi over 2? That is not in the restricted domain. And the restricted domain is 0 to pi. So what we can do is we can go ahead and evaluate the cosine of negative 3 pi over 2. And the cosine of negative 3 pi over 2, that's 0. So now we ask the question, what is the arc cosine of 0? So we ask, where between 0 and pi is cosine equal to 0? And that happens at pi over 2. And pi over 2 is in that restricted domain 0 to pi. But negative 3 pi over 2 is not in that restricted domain, so we can't use it. Okay, arc cosine of the cosine of negative 2 pi. Negative 2 pi is also not between 0 and pi, but we can evaluate the cosine of negative 2 pi. And so we're finding the arc cosine, and cosine of negative 2 pi is 1. So we're asking ourselves, what's the arc cosine of 1? So where between 0 and pi is cosine equal to 1? That's at 0. Okay. One last thing here, we're going to evaluate some more compositions. So this time we're going to do what's the sine of the cosine of negative 2 over... what's the sine of cosine inverse of 2/3? Okay. So the cosine inverse, that's an angle, and so that's going to be either in quadrant 1 or 2. It needs to be in quadrant 1 because the cosine's positive there. That ratio, 2/3, is positive. Okay. So in quadrant 1, cosine is the adjacent, which is 2. Adjacent side, and the hypotenuse is 3. Use the Pythagorean theorem to find the missing side. So 3 squared is equal to 2 squared plus b squared. Call that b. So b is going to be equal to the square root of 5. Okay, and the sine is going to be opposite over the hypotenuse, opposite being the square root of 5, and the hypotenuse being 3. Okay, we'll play the same game with one other one. We'll look at the cosine of the tangent inverse of, what is that there? Negative 2/3, okay? Arctangent is going to give us an angle between negative pi over 2 and pi over 2, so that's quadrant 4 or quadrant 1. Tangent's positive in quadrant 1, so because we have the negative 2/3, we need to be in quadrant 4. Quadrant 4, there's our triangle. Okay, tangent inverse of negative 2/3 is the angle. Tangent is opposite over the adjacent, so the opposite side will be negative 2. That's consistent with if this was the origin here. Okay. And then the adjacent is 3. We'll do the same thing. We'll find the missing side, the hypotenuse in this case, with the Pythagorean theorem. That's going to be the square root of 13. And cosine of this angle is going to be the adjacent over the hypotenuse. The adjacent side is 3. Hypotenuse is 13. If you want to rationalize it, that's going to be 3 root 13 over 13. Okay? So, a lot of information here. This should all be review. Hopefully this helps refresh yourself with some of the concepts of trigonometry.